part 2. Can you turn with me to question 7, part 2 of a tutorial? Yu Tong told me I've done part 1. I did part 1, right? Someone else did part 1, is it? Okay, so do I have to do, yeah, Kailash did part 1, I remember. Someone did part 2, isn't it? Okay, in that case, let's start part 2, okay? Part 1, you can look for Kailash, okay? He will get you through very carefully. For tutorial 7, that question. Okay, let's do 7 part 2. Part 2, hey, can we have some silence? Okay, what is this question about? We got x divided by okay, in this question, you have to note something, no? That the numerator is equals to 0, but the limit, right? The limit of the fraction the limit of this fraction, right? Okay, there's something I forgot to do. I got to disconnect. Class, that suggests to you that the limit of the denominator, yeah, has to be 0, no? Which implies that Kailash and company, what's going on there? Okay, small issue there. Okay, so bearing this in mind, we are not able to progress from this line to say that this becomes limit. Okay, so therefore this implies that okay, we can do this, right? This gives you x plus a minus b square equals to 6. So because of our conclusion here, this therefore is 0. And because it's 0, I can now do this cancellation, and that implies that root a, and let me call this equation 2. And what is my equation 1? So now solving these two, a equals 9, is it? And then b equals what much? 3. Therefore, a plus b is equals to 12. Okay, that is actually our 7 part 1. Oh, part 2, sorry, part 2.
What is 9 plus 3 year 5 version?
Okay, then we got embark on 7 part 3. you have group out yourself. You know, this is same position. I get mixed up. Two classes. Okay. Okay, for SEM part 3, right? You are given limit x goes towards infinity of square of x squared plus ax plus b minus x. Okay. So from here, right? From here, we can do the same thing as before. What can we do? You can multiply by the conjugate so that the denominator becomes like this. And then the numerator, right? The numerator will be equals to ax plus okay. Then to work up this limit, right? We divide throughout by yes. You got something, Reese? You got something, Reese? Just Reese. Oh, okay. Okay. Okay, you see, okay, let's go back to SEM part 2, okay? There's a question raised. SEM part 2, right? You see, this numerator limit, right, will be 0, right? If this numerator is 0, and if the denominator is not 0, right? If the limit of the denominator is not 0, then this whole thing has to be 0, no? But because it's not 0, but because it's 6, that suggests to you that the limit of the denominator has to be 0, otherwise it won't work. Okay, Ming. You understand? And then that allows me to draw this conclusion. Okay, that's SEM part 1. Let's press on with SEM part 2. Okay, for raising a question, can you tell me what I will write on the next line? If I remember, her name is Ke Yue, is it? Sorry. Ting Hui. Okay. Okay, Ting Hui, what do you think I'll write on next line? A plus B thing over 1 plus A plus brilliant. Okay.
How do you go from the first to the second step?
This step to the step, is it? Okay. Multiply by the conjugate. Multiply by the conjugate. The conjugate is actually.
How do you get here?
That's what I did, you know. I have multiplied by the top and bottom, right? By the same thing. And this implies that you can get A plus 0
Why do you flip it around?
Okay, if I want to give a reason why it can be any real number, you will say because the limit right is independent of B. Of B. Okay, let me write. Okay, so we see it all in one go. As a digesting 7 part 3, I want you to know that I've sent out the assignment 1. If you can do it by this week, all the merrier.
When is it Friday?
Friday can.
In the answer you put that B must be any constant.
What's that?
It says that B needs to be any constant in numbers.
A real number is a constant number.
No, we won't have math. We won't have math on Friday.
No, because like some of them they say like
Just put it into the pigeonhole. Okay, Kailash says, Mr. Lim, he doesn't like to have this term any. Okay, so okay. Okay, so I will just bite in. Okay. Alright, I'll take a point. Sure, if you insist. Okay, that is number 7. Part 2 and 3. Okay, any questions you wish to raise about 7 part 3? Okay, number 8. Number 8. That's number 8 again. You are given a function gx and you're asked to find the limit of, okay, part 1. Limit x goes towards 0 of gx. Hey, don't hold hands in class, don't scare me, I'm forced to take action, Years ago, I was teaching in another school. Parents came to see me. He said, can you please advise my boy not to have a girlfriend in school? Whoa! He told me like that, my mother. So I told my mother, cannot. Then she was shocked, she was very shocked. I said, why, I said, because in my school days, I also had a girlfriend, But it's not encouraged, okay? I remember I was called by school. And my form teacher called me up, and her form teacher called up, and my form teacher told me this thing, say, you know why you have a girlfriend at this young age? He said, because you came from a boys' school, and she came from a girls' school. We had a 4-year secondary school before go JC, She was at the 4-year secondary school before she went to JC. She said because he came from boys' school and she came from girls' school. But I wasn't from RI, I was from the best boys' school named after a woman. No lah, Victoria. We are the only school in Singapore that has produced 2 presidents. Yeah, Victoria has produced 2 presidents. The only school in Singapore. One of them was Devon Nair, long ago. The other one is S.R. Nathan.
How have I become president?
Huh?
How have I become president?
Okay, are you ready for math? Part 2. Given that G is continuous, so you can write this note since G is continuous at x equals to 0, then you will know that G of 0 must be equal to the limit G0 according to the definition of G is B, and the limit of this value was found to be 2. Class, in your solution, I tell you this thing, if you have never written this as the first line, and you write this immediately as the first line, you won't get full credit, you may get 0 if it's a 1-mark question. Because we want students to state, you have to state the reason. No, we want you to know that you're using this condition to conclude the next sentence, Jethro, And then part 3. Part 3. So he asks you to use the GDC to do this last bit, G of x So for those who have a GC, what you do is, do you know where to find this notation in the GC?
The book. Yeah, the book button.
No, there's another button, There's a lot of symbol there. There's another button, not the book. Not the book. It's not book. The box. Yeah. Honestly, I find the GC, the button's very small.
Yes,
I find it very hard to see. I need the yeah, it's very easy to make mistake.
Yeah, why do you really quality? This is so
Wow. I hear singing in the background.
Oh, right. Yeah.
Okay, class, if you use a GDC, you ought to get an answer of 0. If you ask me, right, can this be done without the GC? Yeah, you can rewrite it this way first. You can use L'Hopital's rule. To use this rule, the condition demanded is it must be in indeterminate form. And how do you use the rule? Aditi, yeah, clever. You learned this when you were in primary school.
Yes, I learned this when I was in primary school.
You know the way of the hospital.
Yes, that's so true. The hospital.
And again, you have the indeterminate form. So you can do once more.
Wow.
How many times
do you have to do it?
As long as the indeterminate form persists, you can keep going on and on. 没有 You can keep using it as long as the
No, but are there other situations where, like, no matter how much you you will always
Okay.
get determined.
I haven't come across that, but I can create a own, I guess. Cyclic. Like, okay. No, L'Hopital's rule. This one is in chapter 2. The last part of chapter 2 is in chapter 2.
No, I didn't know about that.
You know what roughly is?
Class, as you are pondering over this question, let me ask you, class, I want to find out, are you all prepared to go totally digital? That means,
When doing it for other subjects, it's a huge pain.
no, like what I'm doing right now. I'm fully,
The PRD is going to
okay. Okay, number 9. Number 9. Okay, number 9 asks this question. Number 9. Let's see number 9. Any response from the floor? This is yes, right? Yes, this yes. This exists. What is the value of this? 1. Right, it's equals to 1. And therefore, and hence it is all of the above. Okay, for number 10, okay, for number 10, you are given a question. You're asked to prove continuity on a closed interval. For continuity on a closed interval, the thing you're very careful about is actually the endpoints, no? Right, endpoints. And to do this question, we want to recall a theorem that we had before, no? It says that if G is continuous at x equals to a, and f is continuous at x equals to GA, then fgx is continuous at, do you remember this result we had in the notes? It talks about composition. Okay, it talks about composition. So for number 10, we got to start off this way, no? Okay, for number 10, alright, your function hx equals to square of you start by defining gx as equals to and the domain of G is equals to no, 0 to 4. Okay, we choose the domain of f to be exactly the same as range of G. Can you tell me, in this case, like, what is the range of G? The range of G. So to determine the range of a function, I would suggest to you that you want to sketch the graph of Gx. This is the graph of Gx. and it has x-intercept at 0 and 4, the turning point is at 2, and this is 4. So the range of G in this case is also 0 to 4. Okay? No, we define fx to be like that.
But why does the domain of F have to be range of G?
Because we're going to construct the composite function fg.
If it's a composite, as long as it's a subset.
Yeah, subset is good enough. Equal also can. Okay? So firstly, for every x inside this, okay, let me use A again. Okay. G is continuous at A and F is continuous at GA, so FG is hence continuous on 0 to 4. This is for the interior points, okay? Yeah.
Which part about the graph tells you? How do you infer what you wrote from it?
The range, is it?
How do you infer from the range that like G is continuous at A and F?
Because Gx is a polynomial. Polynomial is continuous everywhere. Square root function is continuous everywhere on its domain. These are known continuous functions. Yeah. So therefore, this statement is true based on the fact that there are functions which are continuous on the domains.
So, wait, so like does it have anything to do with the range like df and rg being the same as dg?
But because in defining a composite function, the domain of f, right,
Must be same as
must be drawn from the range of G. Yeah, that's the reason why. And in this case, I've chosen the range. I've chosen the domain of f to be exactly the range of G.
so like dg equals to df equals to rg. Is that like a coincidence or must that happen for the condition?
Okay, coincidence. It's not always true. It's not always true. In general, it's not. The 3 boys, I can hear you. The last word I heard from him is fair. Can you tell me what fairness I'm talking about? Can you share the discussion? What fairness? Okay. Now at the endpoints, at x equals to 0, we want to check this, no? Limit as x approaches 0 from the right. At the endpoints, we want to check whether or not this is true. This becomes limit and because function f is continuous, this becomes limit and this equals to f of g0 because g is continuous, and therefore this goes to h0. When x is 4 at the other end, you want to check the limit when it tends to 4 minus. You want to show that it is equals to h4. Four minus and this gives you f of G4. Therefore, so number 10, number 10 is a bit, it's just writing. Some people, some years ago, say, Mr. Lim, this question is too obvious to prove, you know.
No.
They say because the function f and the function g, to start with, they are continuous everywhere. So therefore, this question is actually trivial and obvious, you know. I mean, so this whole question is to make you understand about continuity on a closed interval, that you gotta check the endpoints, with limits to the from the right and then from the left at the endpoints. Right. I have never seen a AP question that asks like that kind of question. Don't have, you know, don't have. But this is just for practice. Okay. Then with this, if you're good, we can look at 11. Question 11. Am I too fast? Let me roll back to this. Okay. Question 11, you're very careful, no? It says continuous on the interval and the interval. Be very careful. Between 0 and 1, nobody knows. Nobody knows, okay? Yeah. They didn't say.
So anything is 0 and 1 automatically.
Yeah, between 0 and 1, anything between 0 and 1, like this one, straight away, you can't tell already. Scam. Okay, scam. Okay? So then between -2 and -1, yes, there's a change of sign. And then between -1 and 0, right? -1 and 0, there's also change of sign. Yes. So therefore, these two are okay. This is not okay. So therefore, the answer is B.
B for 2.
Confused.
On negative 2, negative 1, and negative 1.
Okay, let's do number 12. Let's do number 12. Okay, maybe it is good to draw a sketch of the graph. This graph, if you draw it right, I think it looks like this. For the short interval, I think it looks like this. I think it's like that. You just GC to draw for yourself, though. And I think this point is 2/3 also. So what happened is the graph of fx look like this. You will need the GDC to write down the coordinates of the maximum point, this point.
You can use your GC for this.
To get the shape of the graph, to shape the shape of the graph. And then it says, comment on the continuity of the given function. You say that the function is continuous on 0, 4/3. How do you know that without GC, right? Okay. This graph, right? Let's see again. What are the values of x that makes it undefined? The x that it makes it undefined is 302, and 302 doesn't lie inside here. 302 is not within 4/3.
That's how I did it, but
Logic. If you want to do it more thoroughly, you want to say start off this way, no? Let A be any point inside here first. And then 2, you check for the endpoints. Okay? So the function is continuous on the closed interval. And so does it have absolute extrema? Yes.
Yes.
You need to check. Yes. Must you check the points for this question?
If just now she was asking me, Aditya was say, how do you actually do it by calculation that is continuous? Yeah, right. Because this point which makes the function undefined is out of this interval, see? So we're quite safe.
So you can assume that every point like under Tut01 is continuous.
Yes, because the numerator is a continuous function and the denominator is continuous function. As long as you avoid the case where the denominator is 0, you are sure that it's continuous.
So for this one, all polynomials, so it's not that hard.
It's a rational function. Yeah. Okay. I don't remember this maximum value, no. Is there someone who has worked it out before? Anyone has worked out this maximum value? Okay. How much is it? 1, is it?
Yeah.
Okay, 1. Class, I want to caution, for this kind of question, right? AP Calculus Examination Board requires you to write down the endpoints. The endpoints are at 0 and 4/3. And also at the critical point. What's the critical point value? Aditi, what's the number?
1 and 1.
1.
Yes, 1.
Okay. So this 1 and this 1. Right. So you can say that this is actually okay. So then from this table, right, you can say therefore absolute mean is equals to 2/3 and absolute max is equal to 1. And that brings the time